Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
All right, let's pick up where we left off yesterday or in the last lesson, depending on when you're watching this. What we decided was after trying to construct those shapes, just knowing 2 out of the 6 parts of a triangle, we determined that you're not always going to get exactly the same triangle if you only have 2 out of the 6 measurements in common between the triangles. Now, you could get the same triangle, but you're not guaranteed of getting the same triangle. So now we're going to do it where we're going to have 3 parts that are all the same instead of 2 parts. Imagine now that 3 possible measures for your triangle, 6 parts, either the 3 angles or 3 side lengths, or a combination of a couple angles and a side length, and so on and so forth. Do you think everyone will make the same triangle in these cases? So we are going to take these examples and we're going to try and build triangles just like we did before. Hold on for just one moment. Okay, so we're going to start off by taking 3 examples. So you're going to have 3 side lengths that are the same. And we are going to do our best with this tracing paper to create triangles, one triangle or a couple triangles where you have 1.5, 5, and 4.5 centimeters, and then 4.5, 5, and 7, then 1.5, 4.5, and 7 centimeters. So I think what I'm going to do, how many different little pieces of tracing paper do we have here? I think I should probably do what I did before, but I need to add one more of these. And so what I'm going to do is, let me get you out of there. You can watch me as I'm doing this, getting this set up. I'm going to have my ruler out, and I'm going to create one of these that is, do I want that to be in blue or do I want that to be in black? I think I want that to be in black. Hold on for a second. Let's change that so that it is a little bit thicker and it is in black, and that's going to be my go-to now. Does that look like 1.5 centimeters? Looks like maybe it's a little bit long. This is why maybe I should pause it and have all this done. All right, so I'm going to take this guy and I'm going to group them together so that I can move this guy around all I want. I'm going to do the same thing with the 4.5, with the 5, and the 7. And I'll do that pause so you don't have to have your time wasted. All righty, here we go. So each one of these, I've measured them. I was very careful with my measurement. This is your 5, that's your 4.5, that's your 1.5, this is your 7 right there. So what we're going to do is we're going to take 3 prescribed ones. So here's the 1.5, here is the 4.5, and here is, I'll move this guy off to the side. And what we need to do is we need to construct a triangle out of these guys. So maybe I'll start with the 5 as the base, and then I'll move this guy. This is where it starts to get tricky. This is where it's nice to have tracing paper. So you can move these guys around a little bit, and then I'll take this guy, and I got to do it something like this. Oops, stop it. Get this in here. So it looks good, and then is this the one? Yeah, I got to rotate that a little bit. Trying to get these matched up perfectly is not easy at all. So let me actually move it more like this and up to here. I'll take this guy down. Hey, do I need to rotate this guy as well? Is that pretty close? I'm going to call that good. All right. So let me lock all these guys into place. Move you out of here so that they don't move. And now I'm going to trace over this guy and do it in blue. No, I'll do this one in red. So there's my that's my 5. This is my 4.5. And this is my 1.5. Okay, so we're going to try it again, but this time we're going to move things around a little bit. So let me move this guy maybe to here. How's that look? This is my left side. Move this guy maybe something like that. And I'll move this guy like that. And I'm going to have to do some rotating. No, I got to rotate this guy. Oh, goodness, how are we going to make this work? I don't even know. Nope, I want that guy to be moved a little bit. Do I need to... Honestly, this is the same one as before. I'm not sure that we're going to get a different one. I mean, if I move them around... Here, let me actually group all these guys together again. I think all we're doing is rotating it, to be honest with you. If we rotate the position of them, or if we flip them, it's still going to be the same triangle with the same angles. They're just kind of like in a different place. So I'm saying that this first example with those three sides, I think we're always going to get the same triangle. Let's flip this guy back. And let's rotate it again. Yeah, that's the same triangle. Interesting. All right, let's take these guys apart. And now let's get rid of the 1.5 and let's bring this guy into it. So let's see if we can get two different types of triangles out of this. So I'm going to have to rotate this guy up. Rotate it up. Ooh, that's nice right there. That's perfect. All right, let me lock you guys in. Now I'll do this one. Trace over. All right, so this is my 4.5, 5, and 7. Stop it. Okay, so if I try and move these guys around at all, like maybe make this guy on the bottom, and sorry if you hear my dogs barking, they're annoying. And then, is that one, or was this the one? What? No, where's my other one? Where are you? There you are. You need to rotate this way, right? Can I even get this guy? I don't know. How are we going to get this to work? Might have to take this guy and rotate it a little bit this way, so that this guy can get in there. Rotate a little bit this way. That's pretty close. All right, let's lock these guys in. Now to create a blue one, goes from here to here, goes from there to there, and goes from here to here. And group them together. And does that look like the exact same? It doesn't look the same, except when I flip this guy from left to right. And I think I might have just, like with my putting things together, I think those are the same one. I really do. I think this is just like the first example, where when you've got three sides that are the same, the only way we can get these to line up, and of course, this is a horrible example because I think I'm messing. Did I do that right? This was flipped, wasn't it? Yeah, I might have been a little bit off with my angles a little bit. Let me move this guy over and see if this guy can sit on top of it. Might have to flip this guy left to right. Wait, which one did I flip? Well, shouldn't make any difference. Does that look about right? It does, yes. This one's better. A little bit better. All right, so I'm not even going to do the third one because this is getting boring. I believe we can make a conjecture that when we've got all three sides that are the same of two different triangles, the only way that those endpoints can meet up to form a triangle is if all of those triangles have the exact same size and the exact same shape. We worked with two. I'm pretty sure it'll work with the third one. So now let's look at it with angle measures. Let's do the exact same thing. Okay, what do we have? 1, 2, 3, 4, 5 different angle measures. Oh, this is going to be tricky. All right, I'm going to pause and I'm going to do some work here. And then when I unpause, I'm going to have these angles there. I would like for you to try and do this on your own now. Okay, so rather than sitting there and watching me do this, hopefully you've got a protractor. If you don't have a protractor, maybe there's an online tool that you can use here. Let's get out of there for a second. Yes, I'm leaving you. Where are you? Come on, dude, stop it. All right, I get so annoyed with this. Where are we? We are here. All right, but I still don't know how you're supposed to see what your angles are. Where does it tell you the number of degrees in the angles? Oh, that's where it is. It's right here. All right, so this is angle A. Watch what happens when I move angle A around. Do you see how it changes? And look at the total number of degrees that are 180 degrees. All right, so let's do this. I'm going to not use this tool because this is obnoxious. Let's just do the online tool and you can do it as well. So 90, 60, 30. I'm going to go ahead and create a 90, 60, 30 triangle. So it's angle A will be, I'm going to make that 90 degrees. Does that look like angle A? Or you? No. Angle A's got to be 90 degrees. I got to move this over, don't I? Now it's 90, well, close to it. We're going to make it work, okay? And angle B, let's make angle B the 30 degrees and make angle C the 60 degrees. Angle C, 60 degrees. Keep going. There we go. Right there. That's as close as we're getting. Can I make this? What's going on here? That's about as close as we're getting to 60, 30, 90. All right, so that's the shape of this. What happens if I bring this down a little bit? Is it a little bit better? No. Do I have to move this guy over a little bit? There's my 30 degree. There's my 90. Okay, that's all right. That's pretty close. So 90, that's rounds up to 30. That rounds down to 60. So that's what it looks like, right? Can I take a picture of that? No. Let's just. Can I duplicate this? Get another one? I don't know if I can. Let's now move this guy over to here to make it 90 degrees. And then I'll move this guy up. So still 90 degrees. That's pretty close to 90 degrees. Let me move it this direction a little bit. No, it's going too much. That's better. This is, now I got to move it up like this to make this more like 60 degrees. And that's the same triangle. It's just been rotated, right? It's rotated 90 degrees this direction. So I'm beginning to think that 90, 60, 30 triangles, if we were to create those triangles, they would always be the same shape no matter what. We just did it twice, and that's how it worked out. And what's the next one? 90, 45, 45. Okay, so let's do this one again. Make this my 90-degree angle. Does that look like it's pretty close? And we'll make C and D be 45 degrees. As close as we can get to 40. Not, come on. 45 degrees. Why can't I get this to be 45 degrees? Okay, that's pretty close to 45. Yeah, that's pretty close. 90, 45, 45 looks like this, right? I think this should probably be down a little bit more. Yeah, that's pretty close. Okay. Now what if I move my 90 degrees up? Come on, move. There we go. Let's make this one, the B is now the 90 degree, and 45, 45. Yeah, it's pretty much the same. It's just been rotated a little bit. So I think we can conclude, without even doing the third one, that whenever you've got three sides are the same, or three angles that are the same, you're going to have the same triangle. Okay, so maybe I'll just write this in right here as our observation. If you have three parts of a triangle that are exactly the same, the other three parts will also be the same. Okay, so that's the key. Two parts did not work, but if you've got three parts, whether it's all the same angles or all the same sides being the same, then you will get congruent triangles, which means triangles that are exactly the same measure. So in problem 94, you found that if you were given three lengths to build the sides of a triangle, then if a triangle can be formed, all the triangles would make the same triangle. They were the same. Suppose you start with two triangles, knowing that their three pairs of corresponding sides are the same, as shown right here. So here's triangle ABC, and these marks are showing you that this side, which is segment AC, it corresponds to this side, which is segment PR, and they are the same length because they each have that one line right there. Oops, I don't want to do that. These two are the same. Segments CB and PQ are the same length because they've got the two little hash marks there, and then AB and RQ are the same. They've got the three. So the fact that this side matches that side, this side matches that side, and this side matches that side makes both of those triangles the exact same triangle, okay? Exact same size. So what we can say is that these triangles are congruent. Congruent being the special word that means they are the exact same size and the exact same shape. And we have that resource page available to us again, and that ends day 2 of our lesson. All right, so the big idea here is this. I've said it before, but you might want to write this down. If you have three corresponding parts of triangles that are exactly the same, you don't need to know what the other three parts are. They will also be the same, and you'll have two congruent triangles. All right? All right. Let's move on to our next activity. Take care. Bye.
Hey, feeling good, like I should. When in dark,